Good afternoon, good evening, Bearcats. It's Sunday evening, and hopefully you are watching this and taking really good notes so that we can continue in 2.1 quadratic functions. This is technically our day 2, and I'm recapping the day 1 notes. So the day 1 notes would be a recap right here. All right. So for day 1, we really talked about quadratic functions. The general form would be ax squared plus bx plus c. To graph a quadratic function, you have to go through a series of steps. One of the first things that you would do would be find the axis of symmetry. The axis of symmetry formula is x equals negative b over 2a. That gives you the x value of your vertex as well. So this dotted line going right through the middle of your parabola is your axis of symmetry. Your vertex, it always falls along that line. The next thing you would do is that you would plug in the x to get your y value. So you would plug in x, the value of x for both of the x's in your equation, and you would get the value of y, and then that would give you your vertex point. So you can see here that negative b over 2a actually gives you your x value, and then you plug in to get your y value. Third, you're going to solve the quadratic for 0 equal to 0, and you're going to solve it by either factoring, completing the square, or quadratic formula. Those are all the things we've been practicing the few days before this. This is the part that will hang you up. If you don't understand how to solve, you're going to never be able to find your x-intercepts. When you solve, you set it equal to 0, and your solution is actually your x-intercept. So that would be these 2 points in this particular example. And then finally, we're going to find the y-intercept. And the y-intercept is when the x values are 0, and usually that means it is just the constant at the end of the equation. So, step 1, axis of symmetry. Step 2, use that as your x value for your vertex, plug in to find your y value. Step 3, this is the longer step. You factor, complete the square or quadratic formula to find your x-intercept. Really important. And then finally find your y-intercept. And if you know your y-intercept is on the y-axis right here, it's a mirror image over the axis of symmetry, so you'll be able to kind of walk your way across and put a point on the other side, and that would give you 1, 2, 3, 4, 5 good points on your quadratic, and you would be able to draw your quadratic. So hopefully that helps. If you did not do all the problems 15 through 27 or whatever the 13 through 27 odds. If you did not do those, you really want to make sure that you've done those and practice those because you will have graphing on the test. All right, let's go ahead and work an example. We're going to work number 23 because it's a little tricky. So the first thing we're going to do, in this case, step 1, is find the axis of symmetry. And I just told you, and you can write down again, that is x equals negative b over 2a. All right, let's identify our a, b, and c, our a, our b, and our c. Our a value is negative 1, our b value is 2, and our c value is 5. So let's go ahead and figure x. So x is going to be negative b, that would be negative 2 over 2 times negative 1. That's negative 2 over negative 2, and that would be 1. So our axis of symmetry is 1, and I've already drawn that in over here. The second step is to find the vertex. Well, we know in our vertex that the x value is 1, so we're just going to plug that in for all the x's. Be really careful when you do this when you have a negative. And we're going to take care of that negative when we solve in just a minute. So you would plug this in, and you would say negative and then parentheses. The x has a parentheses, 1 squared plus 2 times 1 plus 5. If you don't do this, you're going to miss it right here at the beginning, So 1 squared is 1, but that negative is on the outside, so that's a negative 1 plus 2 times 1 is 2 plus 5 is 5. So 2 and 5 is 7, and a negative 1, you have a positive 6, so your vertex is at 1, 6. I'm just going to say that's 6, and we're going to put a point right there. We're just kind of sketching today. So now we have one good point, and that's our vertex point of our parabola. One thing we forgot to mention, that negative at the beginning of the problem means our parabola turns down. And that's kind of a really important thing. So our parabola turns downward. Okay, so just make sure you realize that. That's really important. After that, that negative we're going to get rid of in just a minute when we solve, which is our third step. Our third step is to solve. Well, we would do negative x plus 2x, negative x squared plus 2x plus 5 equals 0. When I start solving, I want to get rid of the negative. So I'd multiply or divide by -1, and I would get positive x squared minus 2x minus 5 equals 0. All right, we're going to use the quadratic formula. It does not look like I can factor easily multiply to 5 and get to -2, so I'm going to use the quadratic formula. So in this case, our A, B, and C have changed a little bit when we're solving. This is a big, big thing. So I may ask you about this in class tomorrow. I may even ask you secretly to tell me something about this part, and that's the way I'm going to know you watched. All right, so now our A is +1, our B is -2, and our C is -5. So let's go ahead and put it in the quadratic formula. So we have a negative B. That's a -2. So we have 2 plus or minus the square root of parentheses B, which is -2 squared, minus 4 times A, which is 1, times C, which is -5. And it's all over 2 times A, which is 1. And remember how we worked this the other day. So I would say 2 plus or minus the square root of the discriminant, that number we're going to figure out in a minute, over 2 times 1 is 2. -2 squared is 4. And then you have a -4. Remember, this goes with the 4. A -4 times 1 is -4. -4 times -5 is +20. So you have a +20, a +4, so you have 24. Now, we're going to go ahead and since we're trying to graph, we probably want a decimal form of that. I'm going to go ahead and simplify it in case I were to ask you to write it out. You want to go over and simplify the 24, the radical, and you divide by 2 and get 12, divide by 2 and get 6, divide by 2 and get 3. All right, got to take out pairs for a square. So you got 1, 2 out of the house. These don't have friends or don't have any pairs, so they stay home. So multiply that together, and 6 will stay in the house. So you'll have 2 square roots of 6. So now you go 2 plus or minus 2 square roots of 6 over 2. Remember, this is the same as 2 over 2, and then 2 over 2 square roots of 6. So you're going to be able to reduce all of these to 1s, and you're going to have 1, plus or minus the square root of 6, and that would be your 2 roots. Now, when we put this in decimal form, think about it. The square root of 6 is somewhere between 2 and 3. So it's between 2 and 3. If I say 1 plus, let's just say 2.5. It's not 2.5, but that makes it easy to think about. So if we say 1 plus 2.5 would be at 3.5. So it's going to be 3 point something. And we're just going to say estimate. All right, 3 point something. I'll just say 5 for right now. It's not really 5. And we'll make sure those are really wiggly. All right, and if you said 1 minus 2.5, 1 minus 2.5, you would have a -1.5, approximately -1.5. All right, and so that would be an approximation of where your x-intercepts were. So 3.5, we know this is 1, so there's 2, 3, 4, so somewhere in between 3 and 4. And on this side, we would go backward 1, 2, 3, and this is -2. And so when you count backwards, you'd be -1.5 or somewhere in between there. All right, so now we have these two values and a vertex. We already knew that the graph turns downward. All right, last step, number 4, we want to find the y-intercept. That is when we make all of the x values in the original 0. All that goes out, and we have 5 is our y-intercept. So it's 0, 5. So we go over here. We knew that was 6. So at 0, 5 is our y-intercept. You can count over 1 to the axis of symmetry, count over 1 the other way, and put another point. And now you have your 5 points, and you can draw in your parabola. Hopefully this feels pretty comfortable for you. This is one of those things I would go back and review and make sure you've stopped and started as many times as you need to make sure you have this concept down. Graphing a quadratic is something that you will do forever in math, and this is probably the last time to actually get real specific instruction. In the future, your teachers are just going to expect that you really remember and know this. Okay, we're going to move on to the new stuff for tonight. Okay, we're going to go on to problem 39, but before we do, we need to review one quick thing. We need to review the standard form of the quadratic. I gave you the general form of the quadratic formula, or quadratic equation function a while ago when we had the ax squared plus bx plus c. There's another form of the quadratic, and we used it at the beginning of this section. Also, you're very familiar with it, and we often refer to it as our graphing form or our transformation form. But it is really technically called the standard form. I'm going to go ahead and write it down for you over here, and you'll want to have this written in your notes. Standard form. Here it is. F of x is equal to a, parentheses, x minus h squared plus k. And a couple things we need to identify. The h and the k are your vertex, and the a is something that you will find, you will solve for, and then of course f of x is the same as y, and your x and your y, let's see if I can do this without making a big mess. Your x and your y are a ordered pair on your graph, so it's a point on your graph. Because what we're doing today is we're actually being given a graph, and we're being asked to write the equation after having a vertex and an ordered pair of the graph. Sometimes you might even have two ordered pairs on the graph and not even a vertex point. So we're going to be able to find all of this out. So let's look at 39 over here, and we're going to identify a couple of things. Our h and our k is our vertex point, so we're going to go up here and label this h, k. I think that's really important. We also get to pick a point, x and y, that we're going to need. It does not matter if you pick the -3, 0 or the 1, 0. It will not matter. You'll get the same equation. We'll just pick the 1, 0 since the numbers look a little simpler. Okay, so let's get started here. Let's go ahead and plug in what we know. We know we've identified an x and a y value. This is our x and our y, and we've identified the h and the k. What we need to find is our a value. So over here I'm going to write h, k equals -1, 4, and x and y for this problem that we're going to use the 1, 0. And we're going to start substituting into our problem. So our y value is 0, so we're going to plug in 0 for the y. So we have 0 equals. We don't know the value of a, we need to look for a. So a is our big question mark here. We're going to put a parentheses. X, we know x to be 1 minus h. All right, h is -1, so minus a negative, so that's going to be plus 1 squared plus k, and k is 4. And so we can simplify this and solve for a. So the first thing we would do is we would have to move the 4 over. And so we move the 4 over to the other side, we have a -4. So we have a equals 1 plus 1, which is 2, squared equals -4. So 2 squared is 4. So we have 4a equals -4, and the value of a is, divided by 4, is -1. So our value of a is equal to -1. And now we can write our equation just like before. When we write the equation, we're going to leave the h and the k. Those are constant. That's a vertex. That doesn't change. But we want to look for points on the graph, and we're going to use the a value, our a value, and write our equation. So our equation would be, we leave the x and y as variables. So we're going to say y equals a, which is -1, parentheses, x, minus h, which we know is plus 1 because it's minus a negative, squared, plus k, which is 4. And really we could go back and write this function notation. F of x equals -1, x plus 1 squared plus 4. And there would be our equation. Okay, so let's do problem 45. In this case, they give you the vertex and they give you a point. So the vertex, remember, is your h and your k, and your point is your x and your y. And then remember our equation is f of x, or y equals a parentheses x minus h squared plus k. Alright, so just make sure that we have that formula down correctly. Alright, let's start plugging our information in. So our y value is 15. We're looking for a. I'm going to go down here. A equals, and we don't know what that is. We're going to find that. X we know is 7 minus h, which is 5, and then we're going to square that value, and then we're going to say plus 12. Alright, so we want to first solve for a. So we're going to subtract the 12, and when we do, we'll get 3. And so we'll have a, 7 minus 5 is 2 squared equals 3. 2 squared is 4, so 4a equals 3, and a is, divided by 4, 3/4. So a is 3 over 4. And then you just go back to this part right here, and you fill in your a value, and you leave your h, and you leave your k, and you go back to make your x and your y, x and y. So we're going to write y equals a, parentheses, x minus 5 squared plus 12. Or y could be f of x. And that's the way it works. It's really not that difficult, but it is new. You've never done it before, and I just wanted to make sure you knew how. So hopefully you have the notes, and you can work these problems in class for practice, and I will see you tomorrow. I hope you had a great weekend, and I hope you are safe, and I see you in the morning. Night, Bearcats.